So let's go ahead and solve the following examples. So the first example is evaluate the integral of 3x squared multiplied by into brackets x power 3 plus 1 all power 10 dx. So this is the question that we are supposed to solve. First of all, we should note that this 3x squared is an antiderivative of a function called 3x power 3. You need to take note of that. This 3x squared is the derivative of this x squared, not antiderivative, sorry. Is the derivative of this x power 3. So therefore, because the derivative of this x power 3, it means that when we simplify or we do something for it, we'll be able to eliminate this extra term here in order to get our function to be simpler to solve. So in that case, since this one is the derivative of this, then we can say that let our u should be represent this. So if our u is representing this, remember that this is being integrated with respect to x, right? But if you represent this one by u, it means that we are going to integrate it with respect to u, and therefore this value here is supposed to be what? Du, not dx. So how do we change this dx to du? We don't have to come here straight away and then change it to du. There is a process that you need to pass, and this is what we did in my previous video. So if you have not watched my previous video, you can go there and watch it. But in order to do some kind of recap, let's kind of pass through that process and then proceed to solve the question. So before you can eliminate this dx, it means that you need to pass through some process to eliminate it. So this is how we do it. Now we have agreed that we are representing whatever is in the brackets by u, and therefore we can say that our u is equal to x power 3 plus 1. So this is what we agreed that our u should be. And therefore, what you have to do is that find the derivative of du. So it is going to be du dx. That means that we are differentiating u with respect to x. And the answer is going to give us 3x squared. And remember that when you differentiate a constant, it's 0. So now you can see that you have been able to get the x term over here. And we all know that this is the x term that we want to replace. And what do you have to do next? What you have to do next is to make dx the subject. So by making dx the subject, you need to multiply both sides by dx. Multiply both sides by dx. This dx here will cancel dx here. And therefore, you are going to get du equal to 3x squared dx. But remember that we want the x to stand alone so that we can replace it by this one. And therefore, we need to divide both sides by 3x squared. Both sides by 3x squared. And therefore, finally, we are going to get the x to be equal to 1 over 3x squared du. Now we can substitute this dx to this. And at the end of the day, we are going to get a function like integral of 3x, let's say 3x squared, and then remember that we represented whatever is in the bracket by u, and then the u is in power 10. And now we are replacing this dx by this one, which is what? 1 over 3x squared du, which is multiplied by 1 over 3x squared du. So getting this, we know that this 3x squared here are the same, and therefore it can cancel each other. So at the end of the day, we are going to get the integral of u power 10 and then du. So now our question has been able to simplify to this. And what this means is that we are integrating u with respect to u. Or let me state it this way. Assuming that we have our y equal to integral of u power 10 du. This means that we are integrating y with respect to u. So that means that u is our variable of integration. And applying your normal power rule, you can get u power 10 plus 1 over 10 plus 1. And at the end of the day, when you simplify it, what are you going to get? You are going to get u power 11 over 11. And don't forget that this is indefinite integrals, therefore you need to bring or introduce your constant of integration, which is the arbitrary constant of integration, which is the c. Now this is what we have. So basically, we got u power 11 over 11 plus c. But remember that in our initial stage, we said that let u equal to x power 3 plus 1. And therefore, since you are done with this, whatever you need to do is just replace it back, and at the end of the day, you are going to get a function like x power 3 plus 1 all power 11 over 11 plus c. So this is how you need to solve this question. You can quickly check by differentiating whatever you got here to see whether you are right. And what you can do is that you take this power, you differentiate what is here, you multiply by 8, and you are good to go. This c is a constant, so when we differentiate, we are going to get 0. So it's going to be 11 multiplied by the integral, a differential of whatever in the bracket, which is what? 3x squared. Because when I differentiate, I'll get 3x squared. And I take the whole function itself, which is x power 3 plus 1 all power 2. When I subtract 1 from, I'm going to get 10. And don't forget that we have 11 here. So this 11 will cancel this 11. And at the end of the day, you are going to get 3x squared into bracket x power 3 plus 1 all power 10. This tells us that whatever we got here, it's the correct answer. Let's move on and solve a second question. In the second question, it says evaluate the integral of 2x dx all over 1 plus x power 2. Seems the question is not clear here. My pen is not coming in now. So 2x dx over 1 plus x power 2. So this is actually the question. This is integral. So as you can also observe here, this 2x over here is the derivative of x squared. So as soon as you see this, you need to know that you can use substitution to solve this. And therefore, you can say that let your u equal to 1 plus x squared. Mostly we make the u represent the one which is the derivative of the other. So this is the derivative of x squared, and therefore we have to make u to represent whatever the x squared is included, and in this case the x squared includes 1, so we can say that let u equal to 1 plus x squared. So in this case, as I said, here is the x, and we want to replace that dx. What we need to do is to find the derivative of this, and we are going to get du dx equal to derivative of 1 is 0, and the derivative of x squared, as I said earlier, is what? 2x. So making the x the side, we are going to get the x to be equal to, I said multiply both sides by dx, and we are going to get the x equal to du over 2x. When you get the u over 2x, come back here and then replace it by whatever we have. But before that, remember that replace the 1 plus x squared by u, and then the question changes to 2x over u dx. And therefore, when we replace the dx, we are going to get integral of 2x over u multiplied by du 2x. Now, we can see that the 2x are common inside, and therefore we can cancel them out. And at the end of the day, we are going to get the integral of what? 1 over u du. Now, we have everything in one variable, so we can proceed or go ahead and do our integration. And we all know that ln of x, which is the differential of ln of x, it's 1 over x. The same thing applies to differential of ln of u is the same as 1 over u. And therefore, the integral of 1 over u is what? Ln of what? U. And don't forget we are plus c because it's indefinite integral. So having that over here, remember that our u equal to 1 plus x squared. And therefore, when you change it, you are going to get ln of 1 plus x squared plus c. And this is your result. Let's also look at the third example. The third example also talks about integral. Let's evaluate the integral of ln 3x over x dx. Let's see something here. How will you do such question? When you get something like that, what will you do to make your life easier? Now let's see something here. When we make u equal to x, which is this one, we are going to get ln of 3x over x over u, because we are replacing it by u. And therefore, when we find the differential of u, we are going to get 1. And how is it going to simplify our question? That means that we are going to go back and then come forward, right? We are not going to achieve any results. So how do we do this? The only thing that you can do is to represent u to whatever you want to represent in such a way that it will make your life simpler and easier. And therefore, we can decide to say that our u equal to ln 3x. So when we say our u equal to ln 3x, we can find the differential of this, which is what? Du over dx. When we find a differential of du over dx, what are we supposed to get? We are going to get 3 multiplied by 1 over x. That is, we differentiate whatever is inside here, we multiply by it, and we find the difference. So we are going to get 1 over x. So getting 1 over x, you can make the x the subject, and when you make the x the subject, you are going to get x, or we are making du the subject, so x du over 3. Don't forget that, because I'll multiply both sides by x, so x will cancel x, so we are going to x du over 3, right? X du over 3, because and here we divide by 3, that's why it was over 3. So now we know that our dx equal to x du over 3. And remember that since we have changed, we said that u equal to ln of 3x, we need to change it, and we are going to get u over x dx. And since we have our dx, we can substitute it, and we are going to get integral of u multiplied by x du over 3. And don't forget that here there's x over here, which is what? X, this ux. And there's an x common x inside, so it can cancel each other. At the end of the day, we are going to get the integral of u du over 3. So getting this integral of u du over 3, what do? You bring the constant out, and then you integrate whatever you want to integrate, which is u du. And at the end of the day, you are going to get u 1 plus 1 over 1 plus 1 plus c. And at the end of the day, you are going to get u power 2 over 2 plus c. And don't forget that there's a 3 outside here. You need to multiply, it's multiplied by 1 over 3. And at the end of the day, you are going to get u power 2 over 6 plus c. And when we replace this one over there, we are going to get ln of 3x all power 2 over 6 plus c plus c. So now, if you want, you can check it with whatever differentiation that I want to do. So with this one, when you want to do the differentiation of this, you take the power, you multiply by the differential of whatever is here, which is times 2 times 3, because the differential of 3x is 3, right? When you get that, you take the function itself, which is ln of 3x, and then you subtract 1 from it. And don't forget that it's over 6. Now you can see that 2 times 3 here is 6, and then it will go off with this. And when you subtract 2 minus 1, we are going to get ln 3x multiply by, and then don't forget that when you take the differential of this one, aside differentiating this and then differentiating the ln, we are going to get still the 1 over x, or let me do it this way so that you can understand which is what? 1 over x. That is all. If you don't get this, you can use the chain rule to just do this and you'll be able to get the correct answer. So this is how we got, and we get to know that this is correct. Some books are there that sometimes they take the length of 3x, the differential of the length of 3x to be 1 over x, which is not true, because what if you are being given length of x? If you are given the length of x, the coefficient of the x is 1, and therefore the answer is 1 over x for the differential. When you are given length of 3x, the coefficient here is 3, so when we differentiate whatever is inside here, we are going to get 3, so multiply that 3 by the differential of the length itself, which is what? 1 over x. That's how we were able to come out with this answer. Therefore, this validates whatever we have gotten here. So to end this tutorial, I would like to say that this use substitution makes it very simple to solve some complex questions. And my next tutorial will be also dealing with some couple of examples in order to at least have some upper hand how you will be able to evaluate some complex function using use substitution. Thank you for watching, and see you in my next video.